We have about half an hour. Jilt from Moorst does the second part. In the first part, I will try to explain you why the Film Academy wants to use real-time techniques, and especially the Unity engine for that. Just to give you a quick overview of what we do at the Visual Effects department, just a small clip. It's a little bit light here, but research and development is a very important part of the visual effects process. What we always try to do in this process to make it more efficient, to make it quicker. There are all kinds of solutions for that, but the main thing is we started with putting things in a computer. What you see here now is a 7 months difference between the first number, it's the moving storyboard, and the end result in the lower down corner. What we try to speed up is the process of putting it in the computer, like this session, the animatic, and the end result. Wouldn't it be nice for the film crew to already have a notion of how the film will look in pre-production, not in post? There are all kinds of things we had as a solution to cover this problem. For example, it started with in post, you know, of course, that tracking the movements of a camera, virtual camera, real camera, is very important. What we normally did, this is a first-year student project. We need all these tracker markers on green screen to cover later on the pilots with the cabin with a reflection and everything on top of it. It's all post-production. Costs a lot of, it's labor-intensive, costs a lot of time. How we could also do this with, we had, since about 6 years, we had a virtual camera. You can do motion tracking also in real time. This is a session, it's a few years later, also with the pilot. This is a recording, this is the virtual camera. The moment you combine these two, you have a preview, so a previs of the scene on set. And this is very important for students who work as a crew in a green screen studio to have real-time performance or real-time feedback of how the end result will look. We are searching for more of these real-time opportunities where there is a possibility to show the director what he wants, to show the cameraman what kind of frame he has to do. It's important. What we already did is making previous in the computer of the whole story. But you see the reaction of the crew, of a scenario writer, of a director was always, what about these puppets? These are not real actors. They are very stiff, they are very abstract, very difficult to see the timing of the scene. So how we could solve this, also there comes the real-time element in. With the virtual camera, you can do this. You have a virtual set, and in real time he combines an actor with a virtual helicopter deck in this case. This is something, it's very important for the students to directly see the combination of virtual and real. Another example is here also. These are all second-year projects. So the students get to learn how to work with virtual real combination on set itself. Here you see that zoom and all the camera information inside, it's been covered together with the real information of the real camera. What we do, wouldn't it be nice, and that was also the attraction of the investigation where Jilt will talk about, how is it possible that when we have an actor in a virtual set, if you put another actor together with this actor, I'll show you an example, is it possible then to have real interaction? When we do it in a game engine, that would be possible. I'll show you here, you have on the left side, just in a few moments, you see the real actress, but she has to react on an apple in green screen. No way that she has real interaction with the Adam, this person, inside one frame. This we try to achieve in real time. And that's the goal of our research in real-time cinema. Jilt will tell you exactly how, which steps we take to achieve this, this quality in the end in real time. So hopefully you will enjoy his talk also. Moet je even de... We have to switch, sorry. Even lager. Yeah.
Okay. I hope you guys can hear me. And can we switch already? Here we go. Welcome everybody. My name is Jilt from Moorst from the Netherlands Film Academy. I'm a teacher at the Immersive Media Department, and besides that I do R&D for the real-time cinema stuff we were talking about. I'll show you a couple of things. Okay, so Harry already mentioned the virtual camera system. I'll show you a quick video that kind of explains how that works. Basically, you cover your ceiling with fiducial markers. You have a tiny camera on top of the real camera that watches the fiducials, so it knows where it is in space, how it's rotated, and the positions. And also there are sensors that transmit the lens data, so you can pull focus, zoom in and out, and the virtual environment will react in the same way. And well, this works really well, except for the fact that this is a closed system. All you can do is put a virtual environment in it, and there's no way to enhance it with other functionality like you could in the game engine, such as Unity. So the first thing that I set to do, luckily they do expose their data, is to combine the prevision system with Unity. And in the next video, it's a bit not so spectacular to look, but this is the first demonstration where you can see that, well, I'm zooming too far in. This is our talent for today. And this black grid is added into Unity, and the bouncing balls are added into Unity. So you can see that the grid stays fairly decently on the floor. This is the registration point, the 0 point of our space. So that's the virtual camera system. The next thing that we acquired was a pretty basic motion capture system consisting of 12 of these cameras. And you can see there's a lens in there, obviously, but the white squares around it, those are infrared LEDs. So they illuminate the room and the reflective markers. So that's a problem I'm going to come back to in the next slide. So here you can see some pretty early results with some karate and some action where some markers are even dropping off. And this is our first test in getting that into Unity. So now we can put real actors in a real-time Unity environment and also virtual characters, and we can stream them in real time. And as I said, why is the infrared LED thing a problem? Well, you have 12 of them on equal height. That means that if they see each other, they see each other's infrared light. So there's a big hole that you're projecting into the space. So what you want to do is aim them as low as you can get so that they don't see each other, and then find some way to get the best overlap between them, because every point in your capture space must be seen by at least 3 cameras. And setting this up is a very time-consuming thing, because every time you adjust one camera, you have to wand and calibrate again, and you have to wait 10 minutes until you know whether you improved or the situation or made it worse. So I made a little tool that pre-visualizes our studio and finds the optimum angle for each camera. So what it does is it rotates them down until they no longer see each other, and then just in increments of 1 degree just tries out various rotations until all the black spots are gone. The red box that you see is a visualization of the problem areas in our mocap space. So this is already a quite nice result, because you see all the black spots are pretty high. So so this really speeds up our process in getting our mocap system working nicely. So that's also a way to use previs. And this could easily have been me at a party yesterday after 5 ecstasies, but what I'm actually trying to do is break this facial capture system. This is called phase shift. We've been using that and streaming that into Unity to drive a character in real time. Unfortunately, last year Apple bought this company, so we can no longer use this technology. So any alternatives, we're really interested in that. Another thing I set out to do was create a bunch of tools that people could use on the set to say, oh, I want a different kind of light situation, I want to change the weather, just to walk around in the environment and have a slider for various types of weather, and controlling that by with your iPad. But then the next obvious thing occurred. You have an interface that is mobile and that you can interact with. And what if you just put some reflective markers on them? Then it becomes a rigid body for the motion capture system, and then you can have an interaction on a position in your virtual environment. So one thing that you can do with that is to make a virtual camera, like the big system that we have, but much cheaper and easier to work with. So I made a little prototype with this. Obviously, this doesn't have markers yet, but uses the internal gyro on the iPhone. But you can see, just by making a really simple chroma key shader, I can put a virtual environment, Paris, for example, and then put actors or colleagues and props inside that. So what used to be a few $100,000 could be really in your pocket. And this is just made in Unity as well. So, and also, and you have to know, this is 2 years ago, before anyone outside of the laboratory had heard of a Vive. But we thought, well, if you put markers on a HMD, then you know where a user is and where he looks. So, really early prototype of that. This is a student, and this is what he's seeing. So, and the fun thing about this research is that our students are instantly using that research and doing projects with it. So the same year that we developed this, one of our students, Cornel Varga, made a big room scale VR thing where a few things, interesting things happened, because the virtual environment was also created physical. So there was a bunch of objects in a science fiction environment that you could interact with, and so there was a rock, there was an altar, there was a statue, and if you put your hand there, you could feel the real thing while you saw it in virtual reality. So he developed that for a year and a half.
It was amazing.
You don't think you can actually reach something with your hand because it's not there in your head?
Really just sort of walk around in a sort of sim-like environment, and it really felt like I was dreaming.
So this was in October and was presented at the Dutch VR Days in the Vondelpark, and our student even got mentioned in the 8 o'clock TV journal, the news. He made the national news. So this is the a film of that. So this is the NOS journaal doing the installation.
Deze techniek gebruiken in speelfilms. Dat is één van de vragen op deze Dutch VR Days.
So this brings me to our new studio, because right up till this point, we've been, every time I've was working on my research, we had to reinstall the virtual camera system, the motion capture system. Spent a lot of weeks before I could even start testing something. And now we're rebuilding the Film Academy floor by floor, and one of the nice results is this permanent studio. So we have a permanent green screen thing with 12 motion capture cameras, and we're going to put some fiducial markers in there for the virtual camera system, and we have a bunch of 5 systems for room scale VR, all in the same space. So this leads me to the next demo. I'm going to quickly start this up. So the idea is that this really becomes a sandbox, a playground for people to explore their virtual environments, to play with their virtual characters, see them in life size. So let's see if it's started up. Okay, there we are. So this is our new studio, and I made this demo just to visualize the plans that we had for the new studio. And this came out just as the first beta of the cinematic effects came out. I was testing them at the same time, so I'm sorry about the too shiny floor. I was getting a bit carried away here. Okay, so we're seeing a lot of things going on here. So this is the camera. Because of the virtual camera system, we know where the camera is, how it's rotated, and the only thing I don't see is the camera person operating it. Here I can just walk to the end result of what the camera is seeing. You can see that he is in Paris again. This is just a person in a motion capture suit, and this is getting streamed in real time over the network. You see the fiducial markers for the virtual camera system, and here's a colleague walking around with an iPad with markers, and I can see over his or her shoulder what they are seeing. because it's all connected. It's using the new Unity multiplayer functionality. So anything one person does, everybody else is seeing it. So this is what it would look like if I would put on a Vive headset and I can just walk around, and I don't have to be in this horrible green studio. I can just step into Paris, into the virtual environment as well. And there's a lot happening here. So that's purple magenta ball, that is actually meant to be someone with an iPhone playing with virtual light and see how that affects a character. So I'm going to keep this running in the background and show you a few videos. So this is a work in progress. This is the end goal, what we're working on. All the major blocks have been developed. So the streaming of the motion capture data on a character, that's working. To show or to communicate the position of each other, that's all the major blocks are working. It's just a matter of time to knit it all together into a functional and usable thing. So that's what we're working on right now. So I'm going to show you a few videos of the process that we're of our development. So one of the things that we're doing is, this is our new version of a virtual camera, because by now we have the virtual camera system, we have a motion capture system, and we have 2 Vive systems. So that means that we have 3 competing systems that keep track of what is where. And that's a bit much. So we're trying alternatives to make life easier. So what you see connected to the camera on top, that's an early Vive controller prototype. We taped that to a camera, so that's Unity knows where that camera is, so we can render the virtual environment from that point of view, and then combine it with what the real camera is seeing. So that looks a bit like this. And obviously in VR, you also have to worry about safety, because if I can't see other people or heavy things, I might collide with them, and that might end up hurting. So, and even before we knew that the Vive was already showing where the base stations and where the controllers were, we were already developing this. And here you can see I'm wearing a Vive headset, and I see a 3D model of the actual camera rig. So I can just, without actually seeing it, grab it and interact with it. So you can see that the camera is the virtual camera, the 3D model is rotating when I interact with the real physical rig. So this is obviously not how I intend to operate the camera, but just to demonstrate how that's networked. So we had a fancy dress party the other day and recorded a little prototype. So this is actually the view from a camera. So chroma keyed myself into the thing, and obviously we're still working out the exact offset between the Vive controller and the sensor. So the moves don't match perfectly yet, but as I said, it's a work in progress. So in this video, you see me wandering around in a big church. And well, you might recognize this guy. Okay, so this is a tool. We've been thinking a lot of what we can do with this technology. I mean, VR for content creation is going to be huge. And this is just one of the examples that you could do. So here I am just making lamps, making lights, and then they have a menu on them, so I can change the color on them, change the intensity and the range. And that way someone from our lighting department can just play with lights without having to lug around physical heavy objects that are potentially very hot, but you can just play very easily with lights like this. So I can just grab them and So our students are already doing that when they are developing their creatures in ZBrush. They're coming to the studio and they playing with lights around them and see them in real size, and that gives you a much better view of what you're actually creating, and this allows for so much more intermediate steps, so much more iterations in towards getting the right end result. So yeah, with 5 minutes to go, I think this is our presentation. We will be available for questions in a special area, but if you want to contact us, here is our contact information. And I'd like to thank you very much.